This is the second time recently I've forgotten to unmute myself at the beginning of the show. This is like show number 84 or something, and I I shouldn't be making these rookie mistakes, but that's okay. That's we make mistakes together. That's part of how this goes. My name is Whitney Lee. Welcome to Enlightning. I'm so excited to learn about Prometheus today, and we have Iris Dyrmishi here to teach us about Prometheus. Iris, will you tell us about yourself, please?
Hello, everyone. And by the way, Whitney, the moment that I couldn't hear you, I had a mini panic attack. I'm sure someone could see my face. I'm like, oh my God, what happened with my headphones? So, yeah, it happened.
I'm sorry to scare you with my mistake. Welcome. We got this. We're doing the thing. Let's build some trust. We're gonna teach and learn so well. We have nowhere to go but up. Tell us about yourself, Iris, please.
Hello, everyone. I'm Iris. It's a very international name, however you'd like to prefer it. I'm a senior observability engineer. I work at Miro, and basically I breathe observability every day. For the majority of my career, I've worked in building observability platform for big companies, and now at Miro, together with my team, we have a high-class observability platform, mostly based on open source, and we invest so much time to make it amazing.
I love
I'm
that.
a
I breathe observability. It's
yeah.
that's wonderful.
Fun
And
fact.
yeah,
Say.
fun fact. Let's hear it.
Fun fact about myself is that I'm a terrible person when you wake me up in the middle of the night. So I
Uh-huh.
will not remember what I've told you. So it's not a good idea to wake me up. But if you ask me an observability question, I will actually answer. And this has been tested and proven. So that's the
Yeah.
extent of the passion for observability I have.
You might not be very nice about it, but you'll give a good answer for
Yeah.
I like the idea that you breathe observability too, because I think observability to me is very visual. Like at least the results is very visual. So breathing it or like it being just in the air, I don't know. It's kind of nice. Um, Thank you, friends who said hello by telling me my sound was off. That's a good way to get everyone to comment at the beginning, so I know you're here. So welcome to Epic Tralala. Thanks for being here again today. And hello to Pavlo. Thanks so much for coming. Yay, we're doing the thing. So to get started, I would love for you to tell me what the world was like before Prometheus that caused it to be created. What problems were out there?
Well, I would start by saying it was pure chaos, but maybe some some people who are a fan of the previous technologies would not be very happy with me. But yeah, I would say that there was a lack of standardization in the metrics, in the monitoring part. So
Okay.
that made it difficult for teams to implement observability properly. We had different query languages from different tools. So, for example, if you wanted to use Graphite, Nagios, CollectD, everything was different. And of course, processing most of the time was done on the client side, which made it difficult for the applications and for the client to handle this load.
That's so I'm actually breathing observability lately too, but it's very new to me. So I went from knowing nothing about observability and now I'm working my way up to breathing it. And one thing that observability seems to have a lot to do with is just data management. Like you're getting so much data and it's processing. Where are we going to process it? Where are we going to store it? How are we going to sample it so we store less? Like it's a lot of it's just a problem of big data. Yeah.
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 It's very big and very expensive as well, because
Yeah.
not only one pillar, which we're talking today, the metrics, but we have logs, we have traces, and all that together can get very expensive if you don't have proper management, proper processing, storage, even proper querying, which is a very important part.
Ah. So before Prometheus, pure chaos. And some of the reasons, no standardization, there were different query tools, and the processing was done on the client side. Yeah.
Yeah, sounds
Yeah.
about right.
Okay. So now Prometheus exists. Is now a good time to say what Prometheus is, or do we need more context?
No, absolutely. It's a great time. And I want to start that by saying that Prometheus is an open source tool, which is the best
Okay.
part of it,
Yeah.
that helps us to collect, process, store metrics as time series data.
Is an okay, that helps us to, you gave me 3 verbs. Collect, process.
Collect, yes, and store. And of course, this is if we're saying on general terms. Prometheus has so many subtools or friends that it works with that has a lot more capabilities than this. But of course, we're going to talk more about it.
I like that the idea of friends, that like tools have friends. You said something about time series. What's the time series part of this?
So I wanted to start first by saying what are metrics, and then we go to the time series because they're both important parts of the Prometheus genre, like the language of Prometheus. If you don't mind.
I don't mind one bit. In the short term, though, will you tell me the end of your definition?
Okay, yes. Data time series. Store data in the form of time series.
In the form of time series.
Yes.
Oh, is it proper to say to store time series data? Well.
Yeah, it could be. It could be. Yeah, it's time. It is storing time series. So.
Okay.
No matter how you put it, it's the correct way.
Yeah, it's just a different language. So I'm like, how does it? Great. So we have what is Prometheus, and it sounds like you want to talk about metrics generally and what metrics are.
Mm-hmm.
So tell me about that.
We're saying that Prometheus collects metrics, but what are these metrics? And I have a cheat sheet, everyone. I have it here because I'm not very good at memorizing everything. And usually we can just Google this information. So, but yeah.
I think every guest ever has a cheat sheet. You're just the first one to admit it.
Yeah, metrics are quantitative data points that give us indications about the performance and the health of our applications.
Quantitative data points.
Mm-hmm.
As opposed to what? Qualitative?
Yeah.
That do what now?
Provide insights into our applications. Well, applications is actually a very narrow thing to say, but it could be applications, infrastructure. It's bigger than that. So yeah, infrastructure and application. Because I'm an architect, I'm an infrastructure girl, so I shouldn't forget about that.
That's another thing I'm learning about observability is like the infrastructure versus the application observability. Whether you're looking at the performance of a single application or how different applications work together, or whether you're looking at the infrastructure, like there's so many people who care about different parts of the system, and some tools address a lot of things and some tools only address a couple.
Yeah, and infrastructure is one of the most important parts, in my opinion, for the fact that we don't only use observability to observe, let's say, but also to scale infrastructure, which is very important on the performance of the applications that are being hosted on it. So, yeah, it's a very important part of observability, the infrastructure. And now, since we talked about metrics and we mentioned time series earlier, I just wanted to be like a flow of how we are sharing the information. So time series are metrics or data points indexed in a time order, hence the time.
Hello, Kormashu. Welcome, friend. I'm glad you're here. So time series metrics are stored in a certain order, or metrics that are stored in a particular order.
Indexed, more like indexed in a time order. But stored works too. Since
Index.
sorry, yeah, go ahead. I love talking about
Indexed
observability. Too much.
chronologically.
Yeah,
Time series metrics are metrics that are indexed chronologically, can you say? Or a time?
that works.
Okay.
That works, yeah, chronologically on a time order. Since time is so important in observability and in metrics in general, because if they weren't stored in a timely order, we would not know when our application failed or we would not be alerted properly. So that would make a big mess.
Time is so important in life in general. Time is like really what gives the context, like how you relate to everything else.
Absolutely.
Cool. This is great. Speaking, yeah. Now what?
Well, I would love to go to some of the most important parts of Prometheus, and that personally are a challenge to me, and I like it a lot. Of course, it goes to the infrastructure. How does Prometheus work? Because, yeah, we say that it's this great tool, but how does it work?
Let's just dig right in on the big stuff. Okay, how it works, how Prometheus works. So are we going, yeah, actually, just tell me how Prometheus works.
So Prometheus is a tool that can be used as a pull-based and push-based for metrics. So how it works, you either pull metrics using Prometheus, which is the most famous or the most used technique at the moment, and that's what makes Prometheus one of the greatest, in my opinion. So pull-based metrics, and push-based metrics is when the application is actually pushing directly, not to Prometheus, but to its very close friend, Prometheus push gateway. So we could use Prometheus in two ways. And basically it would fit in most architectures.
Is pulling metrics the same thing as scraping metrics?
Yes, exactly.
Okay. So, so it can be pull-based or it can be push-based. And using, what's the tool name?
Metrics push Prometheus push gateway. It's like a smaller Prometheus that runs. And I would love to go in the details of how it works, of course.
And then what's a use case for when you even want to push? I've only ever heard of pulling metric.
Yeah, for example, a use case that I would think is we have some small running jobs that could be, for example, running on Amazon Lambdas, or some pipeline that is running and then it disappears. And for example, Prometheus, when it is scraping every 30 seconds. And of course, it needs to have a target. So if this target is temporary, it will not exist when Prometheus is scraping. So the most useful technique would be for them to actually push these metrics at the time of the execution, and then we always have them when they're gone and don't exist anymore. We do not lose visibility over them.
That makes a lot of sense. Cool.
Yeah. So since we talked a little bit more about the push-based, it's very interesting because it is a push-based approach, but at the same time, it's exactly the same as the previous one, as pull-based, how this whole thing works. So we have this part of Prometheus, which is called the Prometheus push gateway, which is kind of a middleman and is always there waiting. And the job, after it finishes its execution or during, it pushes this metric to the Prometheus push gateway, and the metrics stay there. So then in Prometheus itself, we have a scraping job that is targeting the Prometheus push gateway, and it's scraping it on behalf of the jobs. So it's actually very interesting. The first time I heard about this technology, and I really want to talk about it because not many companies or not many engineers know it or use the
Uh-huh.
push gateway, but it's very fascinating. Like just the way that people created it, whoever created the contributors, it was a great way of thought.
So in the end, Prometheus still scrapes Prometheus push gateway.
Yes.
Yeah, that's fun. Um, so I hear about collectors and
Mhm.
collectors is scrape like a telemetry collector, like open telemetry collector. Is it also scraping? Is it another? Is it? Are they doing the same thing?
Yes and no.
Okay.
OpenTelemetry is built is it has a lot more capabilities than Prometheus in a certain way. Again,
Uh
some
huh.
people will be very mad at me about saying this, but OpenTelemetry collectors have Prometheus receivers in them, so they can do what Prometheus is doing to scrape jobs. You
Ah.
can add it there, but at the same time, they also work as a standalone gateway that you can push metrics directly to the collector, which in Prometheus you cannot do. You need to use push gateway. But at the end, OpenTelemetry was built on top of metric collection is built on top of Prometheus. Now, of course, it's deviating and it's becoming more and more different, but in core, it is built on top of Prometheus.
So when I hear about other tools that are scraping metrics, that they're probably built on, in the end, it's probably Prometheus doing it under the hood.
I would say so. A lot of tools are, even their agents, is built on top of Prometheus.
So lots of metric collectors, almost most metric collectors are built on top of Prometheus, if they're not Prometheus directly. Most
I would
others.
say so. Yeah, I would
Okay.
say so. For example, there are some agents that are running at the machine level or at the cluster level, and they are
Mm-hmm.
closer to the application. So they're enhanced. For example, if they're from an independent vendor, they're enhanced to collect more information. But in core, at least that's my opinion, and from what I see every day, everything about metrics collection at this point is based on what Prometheus does.
Okay. Awesome.
Yeah.
What else?
And say
Yeah.
something.
What else? So for metrics to be ready to be collected, or what? How do they need to be prepared?
So for them to be prepared, first of all, they have to be in a Prometheus format, and we can talk about the Prometheus format because it has some specific features that it has. And second, it has to be exposed to a path in your application. So, for example, usually the path is slash metrics. It's self-explanatory. But
Uh-huh.
yeah, it's very important for them to be exposed to a place where Prometheus can discover them. And it's our job to make sure that Prometheus discovers them at the same time, of course.
So for metrics to be, we'll say, discoverable by Prometheus, they need to
Mhm.
have meet these two qualities. These two. So first, they need to be in a certain format. Um,
Mhm. Yeah, the format is, well, honestly, I haven't seen other metrics rather than the Prometheus one, maybe OpenTelemetry ones as well. But yeah, the majority that I've seen is Prometheus. So it's like, for me, it's the default one. But it's
uh-huh.
pretty standard. Lowercase, and then snake. It's snake case, basically, lowercase snake case. It has to have the units and sometimes the time as a prefix as well. For example, seconds. Is it
Okay.
better to give an example, maybe?
Uh, No, I just think in general it's good to know it needs to be in a certain format. Is it
Mm-hmm.
open metrics? Is that what it's called? Open metrics
Mm-hmm.
format?
Mm-hmm.
Okay. Um, if we dig into it more, we can go into it. But for now, for this point, I think it just needs to be this format.
Sounds good.
And then it also, the second thing it needs is to be stored in a particular directory, stored available in a
To be
particular
exposed,
directory.
yeah.
Exposed, that's the word. And cool. We have a new friend here. Hello, Jafar, and thank you for the nice words. Jafar, Jafar says they're eagerly waiting for some demos. I'm sorry, Jafar. We're just going to talk and write today and ask lots of questions. If you want to see some Prometheus demos, if you go to the Prometheus documentation at prometheus.io, there's a lot of great getting started material there. But thank you for being here in the meantime and hanging out with us. Okay, so is this still under, like I'm kind of asking a lot of questions and writing my answers here and maybe taking you off track from your how Prometheus works point.
No, it's all part of it. It works
Okay.
great. Yeah. And the next part that of course, if you have some follow-up questions here, but the next part would be for me to go into more details about the pool-based approach as well, how it works, because that's actually very interesting about Prometheus and the
Okay.
integrations that it has. So
Cool.
So the one great thing about Prometheus is that it's been around for a while. I think it's 11 years now, or maybe more.
Wow.
I could be wrong on this, but it's been around for a while. But it's very impressive that almost all companies have used it as their standard or as a tool one day, because it's so easy to set up, and it has integrations with a lot of tools. Integrations in the meaning of how you discover your targets. Because imagine a company, for example, I work in Miro, and we have millions of targets, maybe so many data points, and we cannot just go and copy paste each one of them and put them in a list and then for Prometheus or Victoria metrics to, in this case, to scrape them. So how would that work? There are some things that are called scrape configs, and they can be static, as I mentioned, but that is only for testing purposes, or if you have very few targets and they're not changing.
Mm-hmm.
So yeah, that could be an option. But also what I have used in Prometheus and I really like a lot, for example, is an integration with console, that all your virtual machines, for example, are listed there, and Prometheus is able to retrieve this list, the path where the metrics are stored, and automatically scrape them. And if you have a new machine that is being onboarded on console, you don't need to do anything by yourself. For example, it has another integration with AWS. If you have a lot of EC2 instances,
Okay.
you add the EC2 config, and it automatically detects them based on, for example, name or something. So I would say it's an important part, the integration with other tools. Yeah.
So what you're saying is there's like so much data to scrape from all over, but Prometheus is so widely used that it's you don't have to set up all this manually, that it's
Absolutely.
probably integrated. That's the point you're making right now, right?
Exactly, yes.
um Prometheus, like, does Prometheus have a competitor? Is there another metrics?
Well, I mean, not a competitor, but I think OpenTelemetry is looking to create its own standards in metrics that is based on Prometheus, but slightly different. So I don't know if
Okay.
I would call it a competition, but something that might substitute it in some places.
Okay, interesting. That's open telemetry. They're so wonderful and also so doing their own thing, which is cool. Rethinking observability. So the pool-based approach, you probably don't need to manually expose your metrics. There's probably a tool that, no matter what you're using on the planet, there's probably a tool to help you expose
Yeah.
your metrics?
Usually this is done by default, depending on the framework that you're using. Right now, every framework exposes Prometheus metrics.
Mm-hmm.
So you don't even have to manually create anything unless you don't want to, unless you want to create some custom metrics that are not exposed by default.
Okay. For anything. Um,
Yeah, and that's the beauty of open source,
mm-hmm.
because every challenge that you might have, there is someone that had the same challenge and made the contribution. Or if you have a challenge yourself, you contribute the solution that you came up with. It's such a big community that there are very few unsolved problems.
uh, I'm ubiquitous. I don't think I spelled that right, but it was a good effort. You.
I don't know how to spell it either, but it looks good. Looks good.
Excellent. Cool.
Yeah. And as a matter of fact, I was just about to mention that, but I see that we have a question in the chat from Jafar. He says, I have a question, and if a prompt query language is needed for Prometheus. Yes, Prometheus' main query language is PromQL, and it is the widely used one. So if you would like to query the metrics or to create alerts based on Prometheus metrics, you have to use PromQL, which is a very cool language, and it has kind of standardized, or at least started the movement for standardization of everything in one.
So
So
is that,
PromQL.
should we put that on the board?
Yeah, somewhere. I was
Maybe not
thinking
yet.
to touch it later when how to visualize and query metrics. But yeah, everything
Okay.
can go everywhere. It's like so interconnected.
That's the observability mindset. Everything everywhere. It's all connected. So how Prometheus works is the metrics need to be exposed, and they have to be an open metrics format, and they're exposed in a particular directory. But don't worry about doing this manually yourself and exposing your own metrics, because Prometheus is ubiquitous, and there's probably a tool, or it's probably going to be exposed for you very easily with a tool and no manual steps. And then once those metrics are exposed, there is a pull-based and a push-based approach to get those metrics to Prometheus. The push-based uses Prometheus push gateway, which in the end pushes it to the gate somewhere, and then in the end it gets pulled from the place that the Prometheus push gateway pushes it to. So then the pull-based way, it's just pulled. And then most other metrics collectors are built on top of Prometheus. So that's how it works. It's exposed, it's pulled or pushed, but it gets to Prometheus.
Absolutely.
Is that enough information to say how it works, or is there more you wanted to add?
I just wanted to add one more thing as well. It's part of the pool base as well, but considering Prometheus is an open source tool, and it also has great integration with Kubernetes as well. So the easiest way to use Prometheus and the easiest way to have observability is to run everything on Kubernetes, in my opinion, because how it works, you have something called service monitors, which you create together with your application, and Prometheus operator, which is a friend of Prometheus, but it is part of the Prometheus tool itself. Finds these service monitors and reads information from it. So in my application with this name, please scrape my metrics in this port and path. And you don't need to do anything else. This is automatically onboarded the moment you are deploying a new application. Prometheus is able to find this automatically, Prometheus operator, and onboards this application in the list of targets that it is scraping. Is this over-explaining? I think I'm
Oh,
over-explaining
no,
this.
it's great. No, no, so there's a Prometheus. I'm going to ask you to repeat it all too. Prometheus uh, operator.
Mhm.
And then it introduces
Service
what?
monitors.
Okay. And those are those like custom resources?
Yeah. Yeah.
Mm-hmm. And what does a service monitor do?
It is basically telling Prometheus in
Uh-huh.
which port and path to scrape my application.
Nice. And it makes it discoverable?
Automatically. Yeah.
Let's talk about that a little bit. Like, so basically in your service, in the serve, how does it work?
So
Like, yeah.
yeah, so it is a very interesting thing. Again, it's based on what I was telling in the beginning about the integrations. So
Mm-hmm.
Prometheus does, Prometheus operator does, it is able to read the service monitors, and based on the name, path, and port, it creates a scrape config automatically. So what it does, it uses a Kubernetes SD config. It basically queries the Kubernetes API with the name of the pod or the container that you're trying, or the service in this case, that you're trying to onboard. So based on that, it creates a scrape config and it gets all the information that it is exposed to us.
So, for each application I want my metrics to be scraped from. Do I make a service monitor for that application and then Prometheus discovers it?
Exactly. Most
Okay.
of the time, service monitors are such a common practice now that they come with the Helm chart by default. No matter, for example, if you're
Oh.
using a general one, a common one, it always comes with it. So it's a very, very common practice.
Likely included with like a third party tools helm chart.
With Helm charts, yeah. For example, if we are using an image that is coming from the community, for example, if you want to run OpenTelemetry, you probably have a service monitor for it to be scraped by Prometheus, even though it collects its own metrics or whichever. Or for example, if you are developing a custom application in your company, generally there's going to be some general Helm charts and you're going to have it included, or you create it yourself. It's just a few lines of YAML. It's very easy to set up in general.
Can we say again? I know you said it before, but can we get on the board what a scrape config is?
So a scrape config is an instruction to Prometheus of what target to scrape, in what path, in sometimes what port.
I'm using too many words. A scrape config tells Prometheus.
Yeah, what target to scrape and when. Maybe that's like
Yeah.
shorter.
Um, Cool. Is there any rhyme or reason to when you want to scrape often versus when you want to scrape rarely? Like clearly, if you scrape a lot, you have that much more data, but then that much more
Yeah.
information. Mm-hmm.
So basically, that will depend on how often you want your metrics to be collected. For example, you can start from 15 seconds, you can go to every 2 minutes. And they both come with pros and cons. For example, if you scrape every 15 seconds, that means that you will get the changes to the metrics a lot more often. But at the
Uh-huh.
same time, how much change can happen in 15 seconds?
Yeah.
So most companies go for a higher scrape config time, which is like 60 seconds, sometimes 1 minute and a half. It really depends. Unless it is something that is very, 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 very critical and you want it scraped every 15 seconds because it changes so often and you really want to be alerted about it or have a visibility, it's
Uh-huh.
usually a good idea to go for like 30 seconds and higher scrape config. I mean, yeah, it's just personal opinion based on experience. Maybe there are other use cases that prefer it differently, of course. But the
But
costs are huge.
the possible window is 15 seconds to 2 minutes. It can't be shorter than 15. It can't be longer than 2 minutes.
I'm not sure actually. I've never
Oh,
tried less
okay.
than 15,
Ah,
but
uh-huh.
maybe it is. It's something that needs to be investigated. But yeah, please don't do it. Because imagine you have 10,000 targets and you're scraping them every 15 seconds, and it's 4 times the price that you have if you scrape them every 60 seconds. And maybe the
Yeah.
information that you're getting is not good enough to justify that amount of data and that amount of money you're spending, because it is
Yeah.
very costly at the end of the day.
Fascinating. Okay. So Prometheus on Kubernetes, there's a Prometheus operator that has introduces the service monitor. And the service monitor is an object you can use to easily create a scrape config based on your Kubernetes application.
Yeah, and well, once you know how service monitors work, is very fascinating. I always took them for granted for some period of my career. I'm like, oh, service monitors, they work,
Uh-huh.
until I actually saw the genius behind it and how it works, and it's actually very great because it really uses the integrations that Prometheus has. It really makes use of all of them to bring some very great features that are very convenient for teams when using Prometheus.
So how does it work? What's cool about it?
So what's cool about it is that again, Prometheus uses scrape configs, and there is an integration with the Kubernetes API. It's called Kubernetes SD config, which is a type of scrape, and it queries the Kubernetes API with the
Mm-hmm.
name of your application, and it gets for example, if it is a pod running, it gets the pod IP, and it based on the path that we have provided, it says, please, okay, I have this application that is called Logstash. I
Uh-huh.
found it on the Kubernetes API. I find all the pods on this service, and
Uh-huh.
I add the path that you provided me in the service monitor, and I'm giving you metrics. it's
That's
Yeah,
cool.
it's pretty genius. It's like a great way of cohabiting between Prometheus and Kubernetes.
That's awesome. And it takes into account when pods inevitably go down and new IP addresses come up.
Absolutely.
Yeah.
Yeah. You don't
Good.
have to do anything manually hard coded, because observability hard coded is really not a good decision. It changes so fast, especially in big companies. Everything moves, machines, pods go down, go up, new things are created, and you don't want to every time be adding something new there.
So what about instrumenting code at the application level? That seems hard coded. Is it hard coded?
Well, honestly, I'm not very experienced in this part. I'm very much an
Okay.
infrastructure girl, so I'm
Uh-huh.
mostly like on the advisory level on this. But uh, yes, there can be chances that you need to do some manual instrumentation, to the point there are some metrics that are not provided by default by the language that you are supporting, and you really need to create them themselves. Then yes, you need to know how to do that. But most of the time, these frameworks are kind of automatic. You just need to install them. You don't need to do anything on the code itself. You
Oh,
basically
okay.
just install a framework there, or something that is, most of the time, some companies have custom made ones based on the community, depending how different they are, or you just get one that is offered by the community based on the language you're using, and you just need to install it and not hard code anything there.
Okay. Unless you want something specific to your application's particular behavior,
Yeah.
in which
And they're
case.
usually called custom metrics.
Mm-hmm.
They're not as common as the default ones. For example,
Okay.
you know that when you're running a Python application, you know some of the things that are happening by default that you need to monitor for Python. And those are usually included in this framework that you are borrowing or that you're installing. It needs to be
Okay.
something extremely specific that you want to have to do hard coding by yourself. And
Okay.
now, kudos to OpenTelemetry, we also have in-flight instrumentation. OpenTelemetry brought that you can instrument your application while it's running. You don't even have to install anything beforehand.
Oh,
So
interesting. Fascinating. Wow. Cool. I mean that it makes sense. I get
yeah.
it. Cool. So where should we go from here?
So there are two paths that I'm thinking about going. The first one is visualizations in Prometheus and the many, many friends that it has.
Uh-huh.
And the other one is architecture. I
Uh-huh.
love the architecture part, so I am for sure going to talk a lot about it. But maybe we can start with visualizations because it's like,
Okay.
I would say it's more natural transition from how it works to how, okay, you collected these metrics, but then what do you do with them other than storing them? Of course, you have to visualize them.
I like to think of visualization as the reward of the hard work of doing all the instrumenting and the collecting and the storing and like, okay, we did all this. Now we get to reap the benefits, which is visualization. Do you think does visualization include dashboards only, or do you think it also includes like being able to query like from the CLI?
You can query on Prometheus itself. Prometheus offers you a UI. Of course, it's not as advanced as it would be, for example, Grafana, that you can build dashboards, but you can query the
Uh-huh.
metrics on Prometheus itself. So yeah, that I would say that the visualization is not only the tools that you can use Prometheus with, which is pretty much everything, but it is how you can use them, which for me it's not something that I do day to day, but a person, of course, we do it for our own applications, but usually this part of visualization is um, property of the service owners. For example, if I own my application, I should know how to visualize, how to create this, for example, even alerting, I would say, is called visualization, but I would say maybe we could categorize it as dashboarding, alerting, and just querying.
Mm-hmm. Dashboards, alerts, queries. And then um, usually the application owner's in charge of it,
Yes,
of how.
because yeah,
Uh-huh.
it's important that part to be in property, or the service owners to be the owners of it, because
Mm-hmm.
nobody knows the application better than them. So for me to create alerting and dashboards on behalf of another team without knowing their application or being a participant on
Mm-hmm.
developing it, it doesn't make sense.
Yeah. Cool. And then
Yeah.
do you want to the
Yes.
part of visualization that's so Prometheus does have a UI. And Prometheus has the query language, the prom query that Jafar mentioned. Should we talk
Yeah,
about what's inherent to Prometheus versus Prometheus's friends, as you say?
yeah. But first, I wanted to say that visualization, it can be
Uh-huh.
pretty straightforward, but at the same time, you need to understand some things about Prometheus, which I guess it's time for us to say it now. For example, we have metrics, but we know what they are, but what kind of metrics do we have? Like a person that is visualizing these metrics needs to know what type they are first, of
Ah,
course,
like
for
how
them
are
to
the
expose.
metrics discoverable to
Uh,
the
n-
service owner?
Yes, or what type they are. For example, I'm going to give you an example. We have counters, some
Mm-hmm.
metrics that are called counters, and they're used for different things. For example, number of requests. The value of them just keeps increasing.
Mm-hmm.
And then we have gauges. I can never say this word.
Yeah,
Gauge.
gauges or got
Gauges. Yeah,
yeah,
it's
yeah.
better. It's better. Gauges that can go, for example, up and down. Let's say, for example, current memory usage. You don't want your memory usage to be a counter, so of course you want a gauge.
Mm-hmm.
And then you have histograms and summaries, which are a little bit more complicated. For example, histograms put the values into different buckets. Summaries, as we know, give a summary of the
Ah.
quantiles. For example, you can have like a 50% 90 percentile, things like that. And it's important to understand, because based on this you will build the visualization for your application.
So these things you're mentioning are they're not visualizations themselves, they're types of metrics.
Yes, which of course they turn into
Fascinating.
visualizations, and you should know what to expect, because imagine that for some reason you have created a metric and you created it as a counter, and for example it's memory usage. You put the wrong name by mistake, and you just see it increasing. It goes over 100, goes 150, and you're like, what is happening? So it is very important to know these concepts and to know how to work with them. And of course, each of these type of metrics need to be queried differently. For example, a counter, you would
Oh.
use like increase, for example.
Um, I
I can
wonder
say
if
them
I want.
again if you were.
Yeah, oh, I definitely do want that, but I'm kind of like debating whether I should put it up here so I have room. Um, types of. Here's what I'm going to do. Uh, different metric types get queried differently. ERIED queried, something like that, I think. Okay, so I want to talk about types of metrics.
Mm-hmm. The very first one, counters.
Okay, counters. And what's a counter, please?
So it's a value that keeps on increasing.
That makes sense. Okay.
Yeah. And for this, we could use, for example, rate, increase to query it, which are functions of PromQL. The second one would be gauge. Again, I always said gauge, but it's gauge. It's
Fascinating.
very. It's not very often that I pronounce these words. I have them in my mind. I type them down, but I don't pronounce them very often.
Okay, and what's a gauge?
So are values that can actually go up and down. For
Mm.
example, memory usage. Honestly, I don't know a better definition than just going up and down and giving an example.
I think of like you have in your car a gasoline gauge, and that goes up and down as you fill it.
Yeah.
Uh huh.
The third one is histograms.
explain what's that?
It basically distributes values into buckets. And a great example for this would be response times.
It's time to zip up my shirt already. Okay. Distributes values into buckets.
Into buckets, yes.
And what's an example?
It's the response times. Response times usually are histograms.
Okay.
And the very last one is summaries, which is kind of self-explanatory. It tracks the total and sum of observations.
Am I still on the board? Cool. Excellent.
Yeah.
What's the example you gave of a histogram?
That was the response times.
Response time. Okay.
Yeah. And based on that, basically, you can create 95 percentile of the response times if it's easier to understand.
So a histogram, something like a response time, it goes up and down. Like it could be longer or shorter, but it's just like sampled. Like there's less or like tiered. So maybe there's it's less data to have to store and keep track of. Okay. And so these are queried and visualized differently.
And at times, these metrics cause something that is called cardinality. Well, it always causes cardinality, which, how can I explain it very easily? How metrics are built, we have the metric name, of course, and then you have some values there, some labels. For example, machine X, URI / iris, let's say. And it is very important that you keep control of the number of labels. So what cardinality is you have one metric and you have 5 labels on it. So how many times this metric is stored on your backend is with a multiplication of the number of one label, of the other label, and of the other label. So imagine you are storing in your metric a path. For example, you have a user that can interact with your application, and you have like 1,000 paths. So every time this is saved, and then this goes into different machines. So you have 100 machines as well. So 1,000 multiplied by 100 multiplied by something else, it becomes like millions of time series that are saved just for one metric. And it's a little bit too much at times.
Yeah. So cardinality is like maybe you're considering what the user, the operating system, the machine it's going to, the different response codes, and if you think of every single possible thing, it gets pretty wild. Okay.
Yeah. While expensive, and you lose some visibility because you have so much data, it takes forever to query.
Okay. It just seems like there's so many. It's already expensive when you do it right, and there's so many ways it could also just like explode on you. Jafar has a question about histogram, about what it means. What does bucket mean that distributes values into buckets?
So the buckets are, for example, if we are using histograms for response times, we can have a label which is like an upper bound. And for example, with this upper bound of 300 milliseconds, we have this bucket, and all these response times are saved in this bucket.
So it's like a generalization. So it's like anything close to the color red, like crimson or maroon or scarlet, it's all going to be stored in the red bucket. And
pretty much. Yeah,
Yeah.
and that's why you use the percentiles. You use them, you create them with histograms generally, because everything is kind of sorted in buckets, and it
Uh-huh.
makes sense to create, okay, the 95th percentile of this bucket, and then you have the results much easier. It's
Okay.
not the easiest metric
So
to use, to be honest.
instead of saving every single response time, you could have ultra fast, pretty fast, medium, slow, embarrassingly slow, and those are the buckets for different.
Kind of. And they're yeah, pretty much. And they're like stored in, yeah, depending on the boundary that you are determining, I would say.
Got it. Jafar, does that answer your question? Does talking about the color red answer your question, Jafar? Um, and then we were moving on to cardinality, which is something I talked a little bit. I did an episode on micrometer, which is like instrumenting Java with observability, and we talked about cardinality during that episode. So I have a small idea of what you mean. But how does cardinality come into play when we're kind of talking about visualization and types of metrics?
Because it is important to keep track of the cardinality depending on the type of metrics that you have and on how you're querying. Because, for example, no matter what kind of backend you are, if you have a crazy cardinality, your querying and visualization experience is going to be different.
Okay.
It's going to take a longer time to load. It will not affect only your metrics, but for the other engineers or other metrics that you're using. So it is part of, let's say, I don't know about visualization itself, but it's important to know that it goes with the metrics, because we like having gauges like changing here and there. We love having histograms, but we also need to know when to I don't know, optimize these metrics, or when they are not supposed to be metrics at times. I mean, sometimes high cardinality comes with a territory and you really need it, but at times you don't. So as an owner of your metrics, you need to know when to drop this label, which brings us to another exciting topic.
I love your passion, Iris. It's the best. Okay, what's the next exciting topic?
So the next exciting topic is when you have high cardinality, or when you have so many metrics, sometimes you're missing some labels, sometimes you have too many labels, sometimes you want to change the name, depending, or you want to add something extra. That's where something very cool in Prometheus and scrape configs comes, which is relabel configs.
Label configs.
Yeah. It's relabel, but I guess it can be counted as both.
I like your brain. Relabel config. Okay, so this is oh, I forgot the G. I was so excited. And what is a relabel config?
So it's a configuration when you have a scrape config, which we talked about earlier. It's a configuration you add immediately after it. And what it does is it changes, it fixes some values. For example, what you can do, you see that you have a matrix with a label that you don't really care about. For example, it is the version of the machine. You know, all your machines are the same version, so why would you need this label just to cause cardinality? So what you do in the relabel config, you drop it. For example, based on the name of the metric and the name of the label, you immediately drop it. And this is not saved on your backend. It saves you performance, it saves you money, makes the experience better in general.
So you drop it to drop from the scrape. Is that an okay way to say it?
Yeah. Basically, you're telling it when you're scraping, drop this. Before you're scraping, drop this. So basically, you don't even ingest that label.
So a relabel config is a Prometheus configuration that defines which metrics to drop from a scrape.
Well, it's not the only thing that it does. It's one of the functionalities. But for example, I am scraping some metrics from an application, and by default, it is status code. But in my company, I do not like to call it like that. I don't know what is a better name for status code, but let's say that it's called butterflies. I want to call it butterflies. So you use relabel configs to change it to butterflies, basically.
Okay.
It's
So
like
does it have a lot?
manipulate labels and metrics. I would say it's a better thing. And then the functionalities are dropping, changing, adding. You can use it to add as well.
So it can manipulate scraped data before it's ingested.
Yes. Well, to be technical, the relabel config does that, but then there is another one which is called the metric label config, which is done after the data has been ingested. But at the end of the day, in the terms of backend, they have the same functionality. But for Prometheus itself, which has to scrape this, it saves some memory and some performance if you do relabeling before.
What does ingested mean?
Well, ingested is like pulled. I don't know. They're the same word for the same thing. Basically, Prometheus is pulling this matrix to itself.
Okay. So, and then you said example functionality. It can manipulate scraped data before it's ingested. And so, for example, drop. What else?
It can add new labels.
Okay. Okay.
And it can change the name of them, for example. Change. It's very general, but that's what it does.
Okay. Cool. So visualization includes dashboards, alerts, and queries. It's property of the app owners. You need to know which metrics are available, and then the different metric types are queried differently. And we talked about the different metric types. And then high cardinality can negatively affect visualization. And then a relabel config is a configuration that can manipulate scraped data before it's ingested, so that you have a better visualization experience.
Absolutely, yeah.
And so it optimizes visualization and performance both.
Yes, and yeah, it optimizes in terms of having less, but at the same time, sometimes having more in distributed architectures. For example, you don't know from which cluster this information is coming, or if you want to add something very specific that is not available from the applications, you can do that in Prometheus. So sometimes it helps with the performance. Sometimes it doesn't, because maybe you're adding something, I don't think it makes a difference, because the type of label that you're adding through the relabeling config is never that heavy, so it will not make a difference. But yeah, it's not always just dropping, it's sometimes adding.
So, but we can say it improves visualization, because even if
Absolutely.
It could improve the performance, or it could improve the experience, but it's improving some aspect, or why would you do it? And is there anything else you want to say about visualization?
Maybe I will not go into very deep details, because I'm very excited about what's coming next, which is the architecture of Prometheus.
Yes,
and the friends.
You, I'm excited too. Yes.
But I just want to say that it is important to know, as we mentioned before, what functions to use to query. For example, we have different functions like rate, erate, increase, max, mean. Yeah, we don't need to go into the details, because it will take us forever, and I think we're already a long way into it. But it's very important to learn how these functions work and with which type of metrics they work.
Okay, let me just list some of the names of ones.
So rate and erate.
IRRATE?
Yes.
Max min, you said?
Yes, max min.
How am I? Max min. And then I'm going to write etc.
Yeah,
But you
it's best. It's so many. It's a completely different science, the querying in Prometheus. And to be honest, sometimes I forget how it's done because I don't do it very often day to day. And I'm like, wow, this is so much information. But yeah, it's great. I mean, once you get the hang of it, it becomes pretty easy.
Cool. So different metrics. So these functions are used with different types of metrics.
Exactly. Yeah.
Different functions are for different types of metrics. Makes sense.
So next, the best part and my favorite part about Prometheus comes next.
Which is architecture.
Architecture, yeah.
I'm let's do this. That works. Yeah, good enough. Let's do
Okay,
it. Prometheus architecture.
Yes. So architecture in Prometheus, there are several ways that you can run it. And I wanted to just mention it, but I will actually talk about Prometheus and one of his friends in an architecture, considering it's one of the best practices right now. But Prometheus can be run as a standalone. Basically, you can run just a Prometheus and collect the information and then query, and you can run a Prometheus in every cluster. But that's not going to be a great experience because imagine you have 100 Kubernetes clusters and you have one Prometheus in each, and you have to query separately. It's a terrible experience in general. So you don't want to do that. But for small scale projects, it works fine. But there is also federated Prometheus that, let's say, you use some leaf Prometheuses in each cluster and you have a central one to query all of them.
I think I'm just verbose today. I'm like, can be run standalone. I should just write the word standalone. I'm getting
I speak too much, that's why. It's difficult to summarize it in one word.
I just so standalone.
Yeah. The next one would be federated.
And standalones for small scale. Trying to. Okay, the next one is federated. And that's when lots of Prometheuses are managed by one centralized Prometheus.
Yes. So, for example, you have 100 Kubernetes cluster. In each one of them, you run one Prometheus, which are called the leaves, a leaf Prometheus. And then you have a central one which scrapes all these leaves, and you have a central place to query. But it can be another mess of its own, of course. Imagine the type of information that you have to do.
Any many Prometheus instances leaves scraped by one central Prometheus. And is there, you kind of are dismissing it. Is there ever a time where this is a good idea, or is it just not the best?
No, it is a good idea. As long as it is properly provisioned, it is a very good idea. I'm just downplaying it because I have a better one coming very soon.
Okay.
So I feel like the most powerful way of using Prometheus is using it with Thanos, which is one of his best friends. Thanos is part of the Prometheus project as well. And it is one of the coolest tools in observability right now, which doesn't have as much recognition as Prometheus because they're used always together. But Thanos is amazing at using what Prometheus has, enhancing your querying and visualization power, but also saving you a lot in terms of storage because it has very powerful compaction. So what Thanos does, it basically compacts, queries, and stores Prometheus Prometheus metrics.
I'm gonna be compact stores and queries. I'm gonna put it in a different order.
It's probably best, yeah. Compaction is before
So
storing.
it gets compacted, it gets stored, but it's still queryable.
Yes.
For those of you who are interested in Thanos, we're doing a Thanos episode next week on Thursday. Yeah.
Okay, I will not talk a lot about it then. Just a little sneak peek.
Yeah. No, this is great. And then when you say he and his friends, you're talking, they're like mythical or Greek figures. Who actually is Prometheus and who's Thanos? Or are you talking about like Marvel?
Honestly, I don't know. I haven't watched any Marvel
I haven't either.
movies.
I just
I
thought
honestly
maybe. Since you brought it
don't
up, I'm
know.
like, well, who are they actually? Yeah.
Uh,
I feel I
but
don't know.
yeah, I consider them friends just as technologies, but yeah, it's not, no Marvel reason
But
behind it. Yeah.
but there are characters, or like I think it's like mythology characters, right? That are
From Greek
Greek or Roman.
mythology, yes.
Okay,
And
you
from
got that
Marvels, I've
much.
heard of Thanos because every
Yeah.
time that I want to get, I go on Google to get a picture of Thanos, like a PNG to add it in a presentation. Always Thanos appears, and I always forget that he exists as a character, and I'm like, what are you doing here?
Yes. I don't think that that like important Marvel moment happened when Thanos was being named, when the technology was being named, or yeah.
Yeah, it's been a while. But
It's
what
like
I love about Thanos and Prometheus working together is that they get the best of each other,
uh-huh.
and it really improves your experience. So I talked earlier about the federated Prometheus. Granted, to be honest, I've never used this myself. It's just a test that I've done and from the readings, because I always went with the approach of Thanos. So Thanos is has one component that it is called a Thanos sidecar, and it runs alongside Prometheus always. And what it does, it gets all the metrics from Prometheus, basically.
Ah. So
And say.
since it's a sidecar, that makes me think we're talking about Kubernetes specifically. So it's
Yes.
okay.
You can run it as a virtual machine, of course, and keep it separately. As long as they
Uh-huh.
have connectivity, it can still get the metrics from Prometheus.
So Prometheus gets the metrics and then hands them immediately over to Thanos, that who optimizes
Yes.
how they're handled.
Yeah, and Thanos also has a great tool which is called Thanos Query. We use Prometheus to query, of course, but sometimes it can have some performance issues, Prometheus, because this data can be huge, and that's where Thanos helps with the performance. So Thanos Query is generally faster and more
Uh-huh.
convenient to use in large scale architectures. And it also has this great thing that if you have a big architecture with several clusters, let's say, but virtual machines as well,
Mm-hmm.
you have alongside Prometheus, who collects the metrics, you have Thanos getting these metrics and querying it on the Thanos query. It's already faster and very convenient. But there is also something great that you can create. You have a central place where you have a Thanos, and instead of it scraping all these metrics and processing all in one place, it actually registers the other Thanos queries as its own. And basically, you only have one place where you're querying all the metrics, but not all the load is on that one where you're doing the queries. It literally
Ah.
redirects you to the right Thanos query where the metric is, which makes it
So
very fascinating.
so all is that called peer-to-peer architecture? When
I would say so.
I think
Yeah,
that there's a name for it. It's P2P, peer-to-peer. So queries happen. I'm just thinking about how to write it on the board. So queries happen across a lot of Thanos instances, but have a unified experience from the user point of view.
exactly.
Um,
It's a great way to keep it. For example, if you're using Grafana or some other visualization tool, you don't have to have several data sources. You have only one, and it takes you, the querying experience is happening on the query that is local, which also improves the experience a lot, because imagine the big chunk of data you had to query if everything was stored into one.
Mm-hmm. Many instances of Thanos can be queried with one interface. Is that accurate? Is that
Yeah, that's very accurate. Yeah.
okay?
Yeah, and there are different ways supported that you can onboard it. We actually had in my previous team, we were big Thanos users,
Uh-huh.
and generally you have to manually onboard the other Thanos queries. But basically, because if you're using a tool like Consul, let's say, you can even automatically onboard them. So if a new cluster or a new machine pops up, you can have this query onboarded automatically at real time. So it makes the whole centralization very nice, but at the same time, you're not suffering with the pain of having all this data in one place and congesting everything. It's very fascinating. For me, this is one of the most beautiful architectures to use Prometheus with.
So it's good for scaling, and it's good for storing, and it's good for querying. Yeah.
Yes.
Cool.
Yeah, the only reason that this solution is not used as much is because you have two components to maintain, and Prometheus, but especially Thanos, are not very easy to maintain if you don't know what you're doing. You learn with the time, but it comes with its challenges because it has so many components: query, store, the sidecar, the compaction, which is a different beast of its own, if I would say.
So what's hard about it is it's complex to get started.
Yeah. And to maintain it after you get started, because depending on the amount of data, it can get quite overwhelming until you learn the ropes of Thanos.
Cool. Ravi's here. Hello, Ravi. Thanks for coming. Uh, Ravi, if you stick around to the end, we always do a recap at the end, so we'll catch you up, and you can just read the board. But thanks for coming. I'm glad you made it. So I've been writing smaller, maybe too small, because I guess I thought this part was going to be bigger. Do you have some stuff to tell me to fill in this last bit of space?
Oh yeah.
Oh yeah. Do we
Of
have
course, always.
You're like, I could talk forever, literally. Challenge me. Is this is the Prometheus architectures part done? Can I draw the lines around it?
Yeah. I don't want to go into deeper details, especially because there's going to be another session with another expert, so it's going to go into a lot more details. I just wanted to give
Uh-huh.
a sneak peek because it really
Because you're a
fascinates me. I
fan.
cannot say it enough.
You're the
So
best.
it's a very great architecture. Yeah. Well,
Uh,
the next part I would say would be alerting, because Prometheus stores, collects, but visualizes. But one way of kind of visualizing, but at the same time not really, is alerting. And
mm-hmm.
Prometheus is, let's say, one of the tools for alert evaluation, which is the most famous at the moment. So it works together with Alert Manager, which is part of the Kube-Prometheus stack. So it's part of Prometheus in one way. And the name is self-explanatory, Alert Manager.
So, do you want what? Tell me about this core Prometheus stack you just mentioned. Should we say what those things are, then dig into Alert Manager?
Sounds good. Sounds good. So the Kube-Prometheus stack is like a community Helm chart that is contributed by so many people.
Core
And it
Prometheus
has
stack. Am I hearing it right?
Cube,
Core
Cube, Cube, Cube,
Cube.
Cube Prometheus
C U
stack. Yeah.
B K U B E.
Kube, like Kubernetes.
Okay. Cube Prometheus stack. Am I on the board? Yes.
Yeah.
Okay.
And inside this Helm chart, it's very easy to find on, you just write Kubernetes stack. It's on GitHub, it's public and open source, of course, and it has Prometheus itself, Prometheus operator, alert manager.
So so this is meant so this stack is meant if you're running Prometheus on Kubernetes. That's what this is for.
Yeah, this makes it easier, so you can spin up everything in one and you don't have to worry about it. But at the same time, you can still run all this, or at least most of them, in a virtual machine if you need.
I started abbreviating Prometheus prom.
Yeah, it's a long word.
I got tired of writing it. Makes it easier to run prom in Kubernetes. It's a Helm chart, distributed as a Helm chart. Well, as a Helm. We know what a Helm is. And then,
Yeah.
hello, Ganatech. Welcome. I'm glad you're here. Ganatech, yep. I like Ganatech's been coming a lot lately, which I very much appreciate. So, and then you're going to say what it includes.
Yeah, Prometheus and Prometheus operator, which we already talked about.
Okay. I'm going to write. Okay, I'm listening.
Mm-hmm. And then it has alert manager, which is the alerting tool. And yeah, I pulled up the GitHub right in front of me, and I can share it if someone is not able to find it. But it's literally the first thing on Google once you search for it. And it has a Grafana there, which is open source Grafana. It makes it easier for the visualization. You spin everything up at once.
Alerting manager, is that what it's
Alert
called?
manager. Alert manager, yeah.
And then, when you say Grafana, is the dashboard implied, or is it Grafana dashboard?
It's Grafana, the application. Basically,
Grafana,
just
the application.
Yeah.
What does the Grafana, the application, do?
So it is a visualization tool. You can build dashboards there, and it also has alerting. I don't know if it is offered in the open source, but I think so. But it's basically a visualization tool that is compatible with Prometheus. You can use it as a data source, and you can visualize. It is much better visualization than Prometheus UI, basically.
Okay. Okay.
Yeah,
We're
and
barely
then
on the screen. Uh-huh.
On top of that, it has Prometheus exporters, which I forgot to mention about. They're very cool as well. So what the exporters are, there are some things, for example, databases. Sometimes you cannot have them as a scrape target. What URL are you going to use, for example, for a database? It's difficult. So what you do, there are specific exporters that get these metrics from the database and expose it as a target for Prometheus, and you scrape these targets. And there are a lot of them available from the community for most of the things that cannot be scraped directly from Prometheus.
What's the difference between something that can be scraped directly and something that needs an exporter?
So, for example, if you have a virtual machine and you have a bunch of applications running there, usually this virtual machine will have like some sort of URL exposed, because it's something that, for example, the host IP or something like that. So what you need to know is just the host of the IP of this host and where it is actually exposing all the metrics. But for example, the database is not running on a virtual machine or anything. It's a database. I don't know how to explain it better. So it doesn't really have an IP or a URL that you can just go to and query it for all these metrics. So there are specifically built exporters to get this information from you, and then you query it or you scrape it from these exporters.
Okay. So it like collects the metrics and puts it in probably maybe makes a scrape config, and then it puts the metrics somewhere where they can be queried.
Exactly. Yeah.
Cool. You wanted to talk about alerting, and I got into this Kube-Prometheus stack. Is this everything? Is there more to it?
There is Thanos Ruler as well, which is a very nice tool, and it can be used for alerting as well. However,
Mm-hmm.
it's not as good as Alert Manager. Even in the documentation, it says that it's not 100% accurate, let's say, or the way sometimes when it is evaluating the queries. So the preference usually for alerting is Alert Manager.
Okay. And then what's it used for if not alerting?
You don't use it.
Uh,
But in some cases, it works great. For example, Prometheus does not by itself standalone support the metrics being pushed to it unless you have a Prometheus gateway, let's say, a push gateway.
mm-hmm.
But Thanos supports it, so you can push metrics directly to Thanos if you prefer, and you can just remove the push gateway, and Thanos together with the ruler are going to evaluate the alerts on behalf and send them to Alert Manager, for example.
Okay.
It's not that Thanos Ruler does not send the messages. It's not like alerting tool in the fact that it will send messages if something is happening. It's more of the evaluation, which Prometheus does better in general.
Okay. Cool. Is that our Kube-Prometheus stack? Did we do it?
Yes, that's it. I can double check. There's a lot of tools there, but basically this chart is made that you can just install it on your Kubernetes cluster or on your computer and just have the whole flow running. Everything is added, the data sources, so you don't have to put any effort. And this is for small architectures. It could be just a one-time solution and you're done. But of course, the more you grow, you have to make it more custom and great. But it's a great way to start to play around with the Kubernetes stack.
Cool. So what would you like to do with this little bit of space?
Well, let's talk about alerting since we started.
Okay. Let's do
So
it.
alerting is very nice. In Prometheus, it's very easy.
Uh-huh.
And basically what happens is that Prometheus
Uh-huh.
evaluates alerts. Basically, alerts are an expression written in PromQL that
Mm-hmm.
Prometheus evaluates. And when, for example, I am saying that when memory is higher than 80%, I want to be alerted. So Prometheus evaluates that. The moment that it fires, it pushes this alerts to Alert Manager, which is a very simple tool. All that Alert Manager does is it gets this alert, you put some sort of information on top of it, and it sends it to the webhook that you have configured. It's a pretty easy component to maintain.
So Prometheus itself generates the alert.
Yes.
Um, and then Prometheus pushes that alert to the alert manager.
Yes, exactly. And there is one trick with Prometheus alerting, is that it really depends the amount of time that the alerting is being evaluated. It depends on the amount of time that your data is stored in Prometheus. So when you're running Prometheus, you have to have some kind of retention time configured there. And for example, if it is 2 hours, that's the maximum amount of time that your alert can be evaluated. For example, if you want to see the memory of my application in the past 2 hours, that's all you can do. If you go 3, it will not be accurate because it does not have the information it needs to evaluate these alerts for you. And maybe that's where Thanos could help. Thanos Ruler could help, for example, because in Thanos, you are using compaction and saving in an S3 bucket or in Azure storage, which is very cheap. And Thanos can actually get this information, which is compacted and very low, and can evaluate it for you. It's not super accurate, but it works. For Prometheus, everything needs to be in its own storage to be evaluated properly. And and it can be, depending on how many metrics you have, it can be quite heavy and difficult to maintain.
Okay. So Alert Manager, after it gets the alert, it uses a webhook?
Yes. some of the configurations you can do is based on labels on the alert, for example, naming or namespace, whatever label you have. You can tell Alert Manager, all the alerts with this label, send them to this webhook. All the alerts with this label, send them to this webhook, and yeah, this kind
Okay.
of thing.
Um, okay. Well, I'm generalizing a lot, but I think it's enough for a lightboard session. Alert manager sends alerts to a webhook is all I
You
wrote.
can add Slack PagerDuty, and it makes it self-explanatory.
For example, Slack or PagerDuty. Great. Look at that, we filled a board.
Yay.
Yay. How do you, is there anything you'd like to add or say, even if we can't write it down? Or I could probably squeeze some stuff into this space. It's a CNCF graduated project, right?
Yes, it is.
Write that down. But what else? Is there anything else you'd like to say?
About Prometheus, I think we have a pretty good summary of the basics. Sometimes some of them even a bit more advanced of Prometheus. I think we have a pretty good summary of everything that goes on. I'm sure that there is a lot more depending on use cases. But yeah, once you learn the basics, then everything comes easy peasy.
um, it's hard to imagine anything observability related being that easy peasy, but stuff is getting more and more automated, I suppose, and more integrated. So at this point in the show, I'm going to repeat back to you everything you just taught me. And also, if any of y'all who are watching have questions, this is the time to ask because we'll be wrapping up after this recap. But so before we started getting into how Prometheus works first, or even what Prometheus is, first we gave some context. You said it was pure chaos before Prometheus. But by that, you meant specifically there's no standardization around metrics. There are different query tools. The processing was done on the client side. And now the processing's done, I suppose, wherever Prometheus is running. Is that correct? Yes. And then
Yes.
also, this was 11 years ago, so a rather long time ago. So Prometheus has been around for a long time, and it is a CNCF graduated project. So what Prometheus is an open source tool that helps us to collect, process, and store data in the form of time series. So metrics themselves are quantitative data points that provide insights into your infrastructure and your application, whatever you're collecting metrics about. We have a question, so I'll go ahead and ask that question. What is the best practice for monitoring multiple clusters in a centralized location? Is it using remote write? Is something like Thanos or Cortex? We're going to do a show about Cortex coming up here too. I don't know what it is at all yet.
Well, I would say that the best way is to definitely use something like Thanos, but it's not with remote writing everything to a Thanos. It's something that I explained a little bit earlier as well. Use the abilities of Thanos to be very distributed. So use the capability of Thanos query. Basically, first start with having a Thanos sidecar next to your Prometheus. It will get all the information from Prometheus, and then deploy a Thanos query next to your in the cluster that you're running Prometheus. And then from a central cluster, you can onboard all these Thanos queries. It can be 100, it can be 200, and onboard them as if they are part of the central Thanos query. And from there, you can query, and your query will be handled where your metrics are. It's
Yeah.
basically one way entrance to query the metrics, but then not all the information will be queried in one place, because imagine having millions and millions of metrics in one cluster. It's going to
Yeah.
explode and you're going to have incidents all the time. So it's great to use these capabilities of Thanos to be super distributed, but the load of the querying is actually done in the cluster where the metrics are being collected from and not in one central place. Yeah,
That's
it definitely use Thanos. I don't have a lot of experience with Cortex, unfortunately, but I've used Thanos extensively and I can vouch for it 100%.
That's awesome. Thank you, Hello Kates, for your question. And one thing I love about your question and answer is that it really, like having a use case, like really paints a picture of the power, like the importance of what Thanos can do. So that's awesome. Thanks. Keep the questions coming. So metrics can provide insights to your infrastructure and insights into your applications that are running. And time series metrics are metrics that are indexed in a chronological way. You said time is so important, and it just is in life in general. So how Prometheus works, I think I'm going to jump around this and say, like, the first thing that happens is the metrics need to be exposed. They need to, and so metrics need to be discoverable by Prometheus. And so for that to happen, they need to be in open metrics format, and they need to be exposed in a particular directory. Now, Prometheus can get those metrics either in a push-based way or in a pull-based way. So in the push-based way, you use Prometheus push gateway. And then, so it'll, you can push your metrics to Prometheus push gateway. And in the end, Prometheus push gateway is just something that gets pulled from later. That's going to be scraped. As the pulling metrics and scraping metrics are the same, two terms to mean the same thing. So that's how pull-based metrics are done. So now with push-based metrics, well, back to exposing metrics. These two things that need to be met to expose metrics, you probably don't need to do that manually. Like Prometheus is so ubiquitous and so well known that no matter what it is you want to you want your metrics from, there's probably a tool that will expose the metrics, will set that up for you, that expose the metrics for you. So there's probably no manual steps there unless you want to collect something super custom. And then a scrape config tells Prometheus, so now that we're pulling metrics, the Prometheus has scrape configs to tell Prometheus what target to scrape from, and what, so this particular directory is defined there, what target to scrape from and how often to scrape. And then Prometheus does the scraping. I think that's everything from a list. Oh, I asked like what kind of competition there is to Prometheus, and you said there are other metrics collectors, but they're pretty much all built on top of Prometheus and maybe enhanced for their particular use case. So that's how Prometheus works, how metrics are scraped or pushed or both. And then we talked about Prometheus specifically on Kubernetes. So there's a Prometheus operator for Kubernetes, and it adds this custom resource into Kubernetes called a service monitor. And that service monitor custom resource tells Prometheus which port and which path to scrape from, to scrape my application that's running in Kubernetes. So Prometheus will then create this scrape config from the service monitor custom resource. But you also said, similar to the fact that there's probably a tool to expose metrics anywhere, service monitors are so, this custom resource is so widely used, it's likely included with whatever Helm chart you're using to put software into your cluster. So that's Prometheus on Kubernetes. And then we talked about visualization, which is the reward from a job well done of collecting metrics. So visualization includes dashboards, of course, but we could also think of querying and alerting falling under the visualization. It's just like using the data that you've collected and saved. The dashboards are going to be the business of app owners in particular, because they're going to know what they need to see about their application. It'd be silly to make it for someone else. And one thing important when you're designing a dashboard is knowing what metrics are available. So different metric types are queried differently, and there are lots of different query functions, and we didn't get into that very much except to just name a few, which is rate, e-rate, max, min, and more. But the different functions are available for different types of metrics. They're related to each other. We'll just say that much. So the types of metrics, there are 4 of them. We have a counter, which is a value that's always increasing. We have a gauge, which are values that go up and down. We have a histogram, which distributes values into buckets. This one we talked about a little more than others, but maybe instead of saying a metric exactly, we could say this metric falls into the realm of very good, and this metric falls into the realm of medium, and this one falls in the realm of bad, and we're looking at those buckets rather than the individual metrics. And then we had the 4th type of metric is a summary, which is making totals of various things. We also jumped into cardinality, which is if you're collecting too many data points, too many different permutations of how your metrics, if your metrics are too granular, they can be really high cardinality, and it can be a really high cost, like compute and storage cost, but also it can negatively affect visualization in terms of having to navigate out all the different data that's being collected. So more data collection isn't always a good thing. So that's something to be aware of. And then finally you introduce, so we have this scrape config, but Prometheus also has something called a relabel config, which is a Prometheus configuration that can manipulate the scrape data before it's ingested. So we use the scrape config to get scrape data, and then this Prometheus configuration, you can say, hey, I want to drop this data. I don't want to save it. Or I want to add labels to all the data that's coming from this particular machine. I want to label it as such. Or you could change the data that's being scraped in other ways with the relabel config. But regardless, you could use a relabel config to improve your visualization, either performance-wise or just in terms of being able to relate the information back to the system itself. How are we doing so far? Good?
Great. It's great.
Okay, great. Then we talked about 3 types of Prometheus architectures. We talked about a standalone 1 instance of Prometheus, which is, it's good for a small scale, but not much else. Then there's federated, where there are many Prometheus instances, and the smaller Prometheus instances are called leaves, and then those leaves are scraped by 1 central Prometheus instance. That's the thing that you're actually querying. And it's all right, but there's such a better, we kind of dismissed it because you're so excited to talk about Thanos and how awesome it is. And we have a Thanos show coming up next week on Thursday, so please come for that. So Thanos is a CNCF project, and it compacts, stores, and queries Prometheus metrics. So instead of the federated version with Prometheus itself, where all the Prometheuses are scraped and then all the data has to be stored in 1 central location, with Thanos, the data can stay federated, like all across your system, and then the central Thanos knows where the data is and then can query. So your data doesn't have to all go to 1 place, which is makes for a better. Sometimes the amount of data is so huge it doesn't make sense to move it around. If you don't need to move, it's easier to move the queries than to move the data. So, but in general, it helps with scaling, it helps with storage, and it helps with querying well. And that's Thanos. And then we talked about the Kube-Prometheus stack. So back to running Prometheus on Kubernetes. The Kube-Prometheus stack is a Helm chart, or that includes a lot of different projects that work well together to run Prometheus on Kubernetes. So besides Prometheus itself, we have the Prometheus operator that we talked about. We have an alert manager that's self-explanatory. We have Grafana that helps with visualization. We have Prometheus exporters, so it helps to expose metrics of places where they're not naturally queryable. And then Thanos ruler, which we didn't talk very much about, and I forget everything we ever said about it, except it helps with alerting, I think you said. But regardless, yes, it's a an advanced use case, we'll call it that. And then we spent our last little bit of board space talking about Prometheus alerting. So an example of something you might want to alert is if your memory is higher than 80%, I want an alert. So then it's Prometheus itself that generates that alert. And then Prometheus will send the alert to the alert manager. And then the alert manager might look at labels and be like, oh, if it's labeled with this, it needs to go here. If it's labeled with that, it needs to go here. But regardless, it's going to take that and alert and send it to a webhook that may do something like post a message in Slack or put it in PagerDuty. And that's it. That's everything we said about Prometheus. What do you think? Do you feel good about our work? Are you happy? Do you think?
It feels great. It feels great. Yeah, I think we made a pretty great summary of the whole infrastructure, and I'm sure that some people that are watching right now are getting excited and they want to try using Prometheus.
Yeah.
So, yeah, great.
And if that's you, go to prometheus.io, and there's a lot of really great getting started stuff there. Where can you get in touch with the Prometheus community if you have questions for people?
On the CNCF Slack channel, there is a Prometheus community. I cannot remember the name very well, but let me check while we're speaking, and I can say it. It's basically Prometheus. If you write Prometheus on the CNCF Slack channel, Slack space, you have Prometheus devs for each language that you're using, so you can find all the channels there, and people are extremely useful. You get a lot of support. Yeah,
I have very much enjoyed your passion, and like I'm so excited to tell you about Thanos. It's been such a joy to have you as a guest. And everyone is saying nice words in chat too. We have an awesome so far and great summary, and just thank you, Iris, for being wonderful and sharing your time and your expertise with us.
Thank you for having me. I had a lot of fun.
Oh, good. We're not quite done yet. We're going to, I'm going to dance our goodbyes and our thank yous. And you're welcome to shake it a little bit. If you want to just wave your hands around, you're welcome to. It's fine. No pressure. Yeah. So thank you so much. Thanks to everyone in chat who asked all the great questions. And thank you to people who watched this